We do have a lab today that you guys are going to be running. That lab involves question of the day, and our question is, how fast does a marble accelerate? Does it accelerate more at a low angle, or does it excel more at a higher angle? So the steeper you make the incline, does your acceleration increase? It would look like this. Which one has more acceleration, with the ramp down low at, say, 1 or 2 centimeters, or the ramp up high at 20 centimeters? Which one has more acceleration?
20 centimeters.
Yeah, the high one. Everybody believes so, but what am I going to ask you to do in science? Test it. You got to prove it. You got to have data and numbers to show that that's actually true. So your setup kind of looks like this. Now, we've been working on 2 formulas so far this year. The first formula is velocity. What is the formula for velocity? Distance divided by time. What is the formula for acceleration?
Acceleration equals the change in velocity divided by time.
The change in velocity divided by time. Now I want to kind of recover that change in velocity one more time. All right? If I'm going 30 miles an hour and I increase my speed to 50 miles an hour, what was my change in velocity? 20. All right? What if I do that? And here's where the acceleration comes in. So I changed it 20. What if I change it, that 20, in 10 seconds? What's my acceleration? 2. All right, we'll just go with the number 2. But what if I change that speed, instead of in 10 seconds, I did it in 4 seconds? What's my acceleration? 5. So you see how that goes together? You have the change in velocity divided by time. So however long it takes you to change your velocity. So for today's lab, we are going to roll a marble down a ramp. So for acceleration, you're going to find the acceleration. How do you do that? What's the acceleration again? Change in velocity divided by time. Correct. Where's the change in velocity at? Or what's the change in velocity mean?
It's your final velocity minus your initial velocity.
Right, your final velocity minus your initial velocity divided by time. So if we're doing this lab, I've got some numbers on the board. Where's your velocity initial? Where is it located? Yes, ma'am.
0.
It's located at 0. Velocity initial is right up here at the top, right? Where's your velocity final located? At the 100. This is your velocity final. So if I'm going to, so we've got those two. If I'm going to get the time, where am I going to time to? Where do I start the stopwatch? Where do I end the stopwatch?
Started at 0.
I started at 0. And when do I end it?
100.
At 100. So I'm going to start the stopwatch at 0 centimeters, and I'm going to time it until it gets to 100. So that one's easy. We can collect that, right? Right? What's velocity initial's value?
0.
0. Why is it 0?
Because it starts at
Yeah, you're setting it down on the ramp, and it's not moving until you let go, and then it starts to roll. So the velocity initial is up here, and it's equal to 0. But what's our velocity final?
negative.
Can we just come up with a number? No, we don't know what the velocity final is. How fast is it rolling at the bottom? Do we know? If we don't know, we have to be able to measure it, right? So how do you find velocity now?
Distance divided by time.
So velocity is equal to distance divided by time. So if I'm going to find the velocity at the end of the ruler, where do you think I'm going to start and end that velocity? Where do I start the stopwatch? Where do I end the stopwatch?
Started at 0 and at 100.
Would that be the velocity just at this end? Or is that the velocity of the whole ruler?
That's the velocity of the whole ruler.
Right, I want the velocity just at the end. So how do I find that? Pick a distance at the end of the ruler. What distance am I going to use? Minus 100. So you're going to use this distance of what? 20 centimeters. So if you do a time right here, I take my time from here to here. Will I get the speed if I know the distance? The distance is 20. The time is from 80 to 100 centimeters. Now I know this is slightly confusing, and until you get into the lab, it's not going to make a lot of sense. But if there's anything you can take away from this lab, I'll be honest with you. Read the instructions. It tells you step by step, not only what to do, but what math to do to find the answers. Make sure you're reading the instructions. So what it looks like is this. I have my ruler. Here's a point for you. It's going to tell you to set your ramp at 4 centimeters to start. You put a ruler here, and then you just start stacking books until you get to 4 centimeters. All right? And then, please don't mark on the ramps to where the 0, the 80, and the 100, don't mark. Take your ruler and just lay it beside the ramp. And then when you put the marble on it, you can start it at the 0 mark and watch it go down until it hits. When it gets to 80, start, stop. And so you can use the ruler as the marks, okay? Questions? Yes?
Can we use anything to stack up
Yeah. You just got to get it to the right heights. Questions?
Yes, sir.
All right, lab is in Google Classroom. Take your time to get it done. You have the class. You do not have time to socialize. You need to work. Otherwise, you will run out of time.